Hi there everyone, this is Zenith and today we'll be doing Physics Paper 1 Multiple Choice October-November 2023 code 9702 and let's get started. Question 1. Student estimates the maximum speed of some different moving objects. Which maximum speed is not a reasonable estimate? Alright, let us first of all work with what we have is most obvious. Because for these kind of questions, there is really no fixed answers, and it's best if you have good general knowledge, and only then you'll be able to make such reasonable estimates. Let's see, first of all, a container ship 10 meters per second. Okay, that doesn't seem really obvious. Let's look with the second one, Olympic sprinter. Olympic means generally they're talking about these marathon races, which usually have a distance or a length of 100 meters. And the top time for the fastest runner was actually 9.8 something. If I am not wrong, yes, 9.8. You could assume any of these values, alright, but this 9.8, to be honest, comes from general knowledge. And even if you do not know what was the top record for the fastest time, you could work with other data values. You first of all, and it's very important for such questions, you convert the units to the standard unit so that you can easily compare them. Right now we have kilometers per second, which means you multiply with 1000, that would be 0.1 multiplied by 1000, that would be 100 meters per second. Now do you see what's the problem over here? 100 meters is the distance for a typical racetrack, and the Olympic sprinter over here is running 100 meters per 1 second. Now that really looks like a unreasonable estimate. So option B is the correct option over here. Racing car 9000 centimeters per second. Well, you need to again convert it to the units, which means you're going to divide by 9000 by the 100 so that you can convert it to meters. This would be basically 90 meters per second. That seems reasonable. The snail and the container ship is also very reasonable, but option B is of course is the correct answer because running 100 meters per second is not really true. Question 2. Which quantity is an SI base quantity? Now over here it's important to note that they're talking about SI base quantity, not SI units. If you are confused between this, you might select the correct option as C because second is of course related to SI units, but that is the wrong answer. They're talking about quantities over here. For example, quantity SI base quantity is mass and its relative SI unit is kg. So not to get confused between these two terms. Alright, we know force is not an SI quantity. Newton obviously not, and also not second because it's not a quantity, it's the unit. Time over here is the SI base quantity, so option D is correct. Question 3. A student takes measurements to determine the constant acceleration of a model car moving from rest in a straight line. The measured values with their absolute uncertainties are shown. The student uses the equation S is equals to 1 by 2 at squared to calculate the acceleration of the car. What is the acceleration and its absolute uncertainty? First of all, let's calculate the acceleration so that we can get to half of our correct answers. So what do we have over here? S is equals to 1 by 2 at square. Let's work with the true values first of all. S, which is displacement here, is 16.5 equals to 1 by 2. A we need to find, and T we have as 15 square. We can put this into the calculator. 16.5, and we get the correct answer as 0.146, approximately equal to 0.15, to two significant figures. So that basically eliminates options A and options B because 0.11 is of course not the acceleration in this case. It's either of option C or option D. Now how can we work out that? Alright, so we basically need to now calculate the uncertainty. The first thing you should do is rearrange this formula in terms of A so that we can see what quantities are dividing, what quantities are adding, and so then we can calculate how to add or divide their fractional uncertainties in this question. So S is equals to 1 by 2 at square. If we rearrange it, that would basically be 2S over t square is equals to a. And now you have two ways of working out this answer. You either calculate the fractional uncertainties, or if you do not know how to calculate fractional uncertainties and then add or subtract them based on whatever data you're given here, you would add them, of course. But if you do not know how to work with that fractional uncertainties and all of that method, you could go with a very simple approach. To calculate the absolute uncertainty, calculate one of the false values, which is basically the highest possible value or the smallest possible value. The formula was 2s over t square is equals to a. Let us calculate the largest possible a. In this case, we're going to take s as the largest value, which would be 16.5 meters plus zero point 0.1 meters. That would be 16.6 divided by the smallest time value. So we're going to subtract time. You could also add into it, but then it would give you a different kind of acceleration and that won't really be consistent with the answer. So we're going to look first of all for the largest possible value. So 15 minus 1, that would be 14 in this case. And now if we calculate a, will be 2 into 16.6 over 14 squared. Most importantly, 14 squared. That would be 0.169. All right. And now how can we calculate the uncertainty in acceleration? You just subtract the values. Doesn't matter in which way you subtract, because the units for the sign for this is plus minus and it goes in the both directions. So 0.169 minus 0.15. And that gives us the answer as 0.019, which is approximately equals to 0.02. So the correct answer will be 0.02 plus minus, of course, because it's uncertainty. And so the correct option will be D. Question 4. An aeroplane is moving at a constant speed in a straight line at an angle theta to the horizontal. Four forces act on the plane: the thrust force T, weight W, lift force L, and resistive force R. Which two equations must be correct? The first thing when you're given a lot of forces is to draw a diagram of the forces. Alright, we're going to first of all have our plane and the horizontal line. Let's mark this as theta. And suppose over here we have the aeroplane. Mark a point on it, and now let's start putting the forces over here. So the first force was R, and then we have the normal force, which is perpendicular, which is lift in this case, and then we have weight, and we have lastly thrust force, which will be T. Now they're asking us which two equations must be correct. So let us now see an equivalent equation for L. For L, it will basically be equal to the vertical component of W, or horizontal component, depends on which angle you're trying to look out for. So it will be basically this vertical component. How do you calculate this vertical component? For this, you must know this property, that if you are having angle theta over here, then the opposing angle over here would be theta minus 90 degrees. All right. And from that relation, you can make out that in the horizontal direction, you will be using cos, and in the vertical direction, you will be using sine. That means L would be equals to W sine theta, or in fact it would be not theta minus 90, it would be 90 minus theta. Right, this would be 90 minus theta. In fact, 90 degrees minus theta. Yes, so W sine 90 minus theta. All right, this will be equals to L. But what's the problem here? The problem here is we do not have such an expression. Well, the another point to remember over here is sine 90 minus theta is simply equals to cos theta, and vice versa is also the case. Cos 90 minus theta is equals to sine theta. That means we have found one of the equation. L is equals to W cos theta. That means it can't be the sine over here, it can't be this option. B and D are completely wrong. It's either option A or option C. Let's see what is T. Now T is equals to R, but not just R. It also has another force. Remember when I said that weight will be divided into its two components? We had calculated the vertical component, but we haven't calculated the horizontal component of weight. So the horizontal component of weight, let's name it as Wx, will be equals to W cos 90 minus theta. Of course, now there is no 90 minus theta over here. So this weight x component will be equals to W sine theta. As I mentioned, if there's 90 minus theta cos, that would be sine theta, and vice versa for sine as well. So Wx is equals to W sine theta. And now you can see where we are going. T is equals to, and because the aeroplane is moving at constant speed, this T must equal whatever forces are acting downwards, R plus some force, which is Wx in this case. So it would be R plus W sine theta. And you can see option A over here is correct. And so this is the correct option A for this question. Question 5. What is the rate? What is the definition of acceleration? So definition of acceleration. Acceleration is what? Acceleration is change in velocity per unit time. Let's see. Rate of change of displacement? No. Rate of change of kinetic energy? No. Rate of change of momentum? No. That would be the resultant force, in fact. Rate of change of velocity? Yes, that is correct. Option D. Question 6. An astronaut on the moon where there is no air resistance throws a ball. The ball's initial velocity has a vertical component of 8 meters per second and a horizontal component of 4 meters per second as shown. The acceleration of free fall on the moon is 1.62 meters per second square. What is the speed of the ball 9 seconds after being thrown? Now, first of all, a common misconception to be addressed. Many students are going to fall for this mistake and calculate one of the speeds and circle the options, while in fact they're asking for the final or the resultant speed. This speed over here is not any one of the component, it is the combined speed, basically initial velocity. So we'll have some final velocity, and that would be the velocity which they're asking in the question, not just any one of the components. So being that addressed, let's see how we can calculate the final velocity. All right, assume any point on the path of the ball. We know that the horizontal velocity will remain constant because there is no horizontal acceleration acting on it, because this is of course projectile motion. And according to projectile motion, there is no horizontal acceleration, but there is some vertical acceleration. So horizontally, the speed will be constant. We have officially then calculated one of the horizontal speeds. But now we need to know the vertical speed. Now it doesn't matter if you're making it up or down, it's just for the sake of understanding. This arrow could be down as well because of course the ball is eventually going down, but that's none of our requirement. We need to calculate this Vy. Alright, so what information we are given? In terms of the vertical velocities, it's important to consider we're only working with vertical velocities. Do not confuse vertical velocity with horizontal and interchange them in equations, because that would of course give you wrong answers. So what informations we are given according to the vertical velocity? We are given initial vertical velocity. I'm going to label it as uy as 8, and we do not know what is the final vertical velocity. We do not know what is final vertical velocity. All right. Do we know the acceleration? Yes, that is 1.62 meters second square. All right. And are we given any time value? Let's see. Time, yes, 9 seconds. Are we given any displacement data? No. So given that you have now listed all of your information, now you can work out what equation will best fit. If you look closely at the data, we have initial velocity, final velocity, acceleration. Final velocity we have to find, we have initial velocity, we have acceleration, and we have time. And we can relate all of this using V is equals to U plus A T. No other equation would really work because you would have to find some extra information for it, such as S. So let us see, V is equals to U plus AT. This is one of the equations that you can use to find this vertical velocity. So v, which is the final velocity, is vy. Uy is 8 plus a in this case, make sure is minus 1.62. Whenever you're working with acceleration in projectile motion, make sure the acceleration should be in fact negative. And then time. What is time? Time is 9 seconds. And now let us calculate. That would be 8 plus minus 1.62 multiply by 9. That would give us the answer as minus 6.58 meters per second. So we have calculated the vertical velocity as minus 6.58 meters per second, which means the arrow basically should be pointing downwards. So this minus 6.58 is not the final answer. As you can see, we have just found a matching answer. Don't just go to circle option A. That is not a final answer. You need to calculate, in fact, the resultant speed. And resultant speed we can calculate just through Pythagoras theorem. So in this case, we need to find the resultant speed. I'm going to label it as V resultant, VR. And according to Pythagoras theorem over here, we can even draw a triangle for the sake of ease. We need to find the V resultant. Vertical one was minus 6.58. Minus won't really matter over here now. And 4 was horizontal. So minus 6.58 whole square plus 4 square. And now you're going to take the root of it. That would be 6.58 square plus 4 square, and you would get your final answer as 7.70 meters per second. And so option B is the correct answer. Question 7. Two blocks of mass 0.2 kg and 0.5 kg are connected by a light inextensible string that passes over a frictionless pulley. The blocks are initially held stationary. The block of mass 0.2 kg rests on a rough horizontal surface. The block of mass 0.5 kg is suspended in air. Air resistance is negligible. When the blocks are released, they have an acceleration of magnitude 2 meters per second. What is the magnitude of the frictionless force between the block of mass 0.2 kg and the rough surface? Alright, so they're basically asking us for this frictional force over here. Let's just call it FD, or F, basically resistive force. Alright, so now this question might seem complex. So the way I approached this question was I absolutely just forgot that this mass is over here. Alright, work out this question without knowing that this mass is over here. Alright, assume a scenario where you are not having any mass, but instead you are holding the string from here. When you will release the string, this mass will fall under the influence of a force. That force will be equal to its weight, obviously, because it's falling freely. That would be the force of free fall. And from there, you can construct an equation for it, that what would be the force acting on it. Suppose if this mass was not here, it would be F is equals to ma, and that F would be basically equals to the weight. So it would be 0.5, that F 0.5 into 9.81, and that would give you 4.905 newtons. And that would of course be its weight as well, but that would obviously also be the downward force acting. Now assume that the mass is there. All right, assume the mass is now there. Now the acceleration has changed, much more has changed. You could now rearrange this equation. So initially the force acting on the system, given that we didn't have this block of mass 0.2 kg, was 4.905 newtons. Well, now we have 4.905 newtons minus some Fd or Fr, basically the resistive force in this case, which is acting opposing this motion of the block. And you might also ask that why we did not calculate the weight of this block Why? Because this has no change in the height. The first thing is that it's going against the surface. It has nothing to do with the change in height, therefore it is not being pulled by its weight. So we do not consider any weight calculations for this mass. Alright, but we do calculate the friction over here. So now we know there was some friction and we are also having this downward force of weight. What will this be equal to? This will obviously be equal to MA. Up till here, if you figured it out, congratulations, because after this, the process is really easy. Mass was zero point 0.5 plus zero point 0.2, the whole combined mass, because you're including the force of this block and the force of this block. 0 0.5 plus zero point 0.2, and the acceleration over here is 2 meters per second square, as given in the question. When the blocks are released, they have an acceleration. Important thing, both the blocks have combined acceleration, 2 meters per second square. And you can equate this back with your 4.905 minus the FD. And then let us solve for FD. 4.905 minus F 0.7 would be the total. 2, and you would get your answer as 0.505 newtons, approximately equals to 3.5 to two significant figures. And so your correct option would be A. Question 8. A resultant force causes an object to accelerate. What is equal to the resultant force? The acceleration of the object per unit mass? Well, let us visualize it in terms of the units. Acceleration of the object per unit mass. Alright. Acceleration of the object per unit mass. Does that equal something? The mass and acceleration are used in F is equals to ma, but that is not absolutely equal to this. That is wrong. So obviously, first option is wrong. Change in kinetic energy of the object per unit time is also wrong. That does not give you any resultant force. Change in momentum of the object per unit time? Yes, because that is the resultant force calculated. Delta mv, which is change in momentum per unit time, will give you a resultant force. Option C is correct. Question 9. An object falls from a stationary helicopter and reaches terminal velocity. What happens to the acceleration of the object between leaving the helicopter and reaching terminal velocity? So they have said an object falls from a stationary helicopter and reaches its terminal velocity. So one thing to note over here, the object falls freely. For any object that is falling freely, its initial acceleration, given of course it is in the earth or close to the earth and not just in space, given that it is falling freely, the initial acceleration will always be equals to 9.81. Alright, and then they have said it reaches terminal velocity, which means acceleration will then decrease to 0. Terminal velocity means constant velocity. Acceleration must be 0 in this case. So now we can begin the elimination of options. Decreases to 9.81? No, 9.81 is the initial acceleration. Decreases to 0 obviously will be correct. Option B is the correct answer. Question 10. Two balls of mass m and 2m traveling in a vacuum with initial velocities 2v and v respectively collide with each other head-on as shown. After the collision, the ball of mass m rebounds to the left with velocity v. What is the loss of kinetic energy in the oscillation? Question 10. Two balls of mass m and 2m traveling in a vacuum with initial velocities 2v and v respectively collide with each other head-on as shown. After the collision, the ball of mass m rebounds to the left with velocity v. What is the loss of kinetic energy in the collision? Alright, so they've said us after the collision, the ball of mass m rebounds to the left with velocity v. We can just draw an arrow over here for the sake of ease, which means it is now having velocity of v. Now they have said what is the loss of kinetic energy in the collision. The loss of kinetic energy, basically delta Ke, will be equals to the K initial or K final, basically kinetic energy final minus kinetic energy initial. But in this case, they're asking us the laws, so the sign really doesn't matter. So first of all, you can see from here that we need to calculate the initial kinetic energy. All right. Let us see what will be the initial kinetic energy. That would be 1 by 2. Let us look for m. M v square. In this case, it would be 2v square plus, because we're adding in the kinetic energies, that would be the total initial kinetic energy. And the other one has a mass of 2m with velocity v, or minus v you could say in this case, but again it really doesn't matter because the velocity is getting squared, so the sign is really negated. So the initial velocity you would get over here, let us see, you would get over here m into 4v square over 2 plus 2 to cancel here, we are left with m v square to 2, and then we're again then left over here with m 2mv square, actually 2mv square plus m square, and that means initial kinetic energy was 3mv square. Okay, so the initial kinetic energy was 3mv square. Now let us work out the final kinetic energy. For the final kinetic energy, we need to know the final masses and the final velocities. Final masses we know 2m and m. Final velocities, do we know them? Well, partially. We know v as one of the final velocities, but we do not know the final velocity of this ball. Let's label this as vf and let's find it. This is a collision. Therefore, we can apply the conservation of momentum in this case. So let us apply the conservation of momentum. That would be the initial momentum of the objects combined would be equal to the final combined momentum of the objects after collision. All right, that would be m into 2v plus 2m into minus v. The signs over here must be very important. And then for the final velocities and final momentum, final one was m into minus v, because now it has changed sign. If you're considering the right direction as positive, we're going to consider the left direction then as negative. An important convention, just keep it in your mind. So m into 2v plus 2m into minus v is equals to m into minus v plus 2m into vf. Now we need to find f. All right. So the first thing we can do is right from here, we can cancel out m. You could also cancel out after doing the whole working, but we know you can just take it out the common and you can remove m like that. So m cancels out. That's the first thing. The next thing, let's just simply open the brackets. So you would be left with 2v, not plus actually, minus 2v. It would be 2v minus 2v is equals to minus v plus 2vf. That would be 0, and then over here v, so vf will be v over 2. All right, so now we're given that the final velocity is v over 2. We have just calculated it. So now we can work out the final kinetic energy. That would be 1 by 2 m v square plus 1 by 2 2m, and other one would be v over 2. And that would be mv square whole over 2 plus 2 cancels. You're left with m v square, very importantly, over 4. 2 over here is also squared. And then you can add them. So basically the fractions over here, you can add them. That would be 1 by 2 plus 1 by 4. And the answer you will get would be p by 4 m square. All right. So now we need to calculate the final kinetic energy, or the change in kinetic energy, in fact. Loss of kinetic energy. Let us see. So final kinetic energy minus the initial kinetic energy, or vice versa we could do. It doesn't matter. We just need to get the magnitude in these cases. Magnitude. So sign really isn't important. But let us just take 3 minus 3 by 4 mv. Or we can just stick to this. Let's just take 3 by 4 mv square minus 3 mv square. And let us subtract these. 3 by 4 minus 3, and we would get our answer as minus 9 by 4 mv square, which indeed indicates that we have lost some kinetic energy. Disregarding the sign, our correct option would be option C, 9 by 4 mv square. All right. Question 11. A force F is applied at an angle 45 degrees to a door handle at a distance d from the pivot of the handle as shown. What is the moment of the force about the pivot? Now, usually you'd calculate the moment as F sine theta. In this case, we can see that we aren't really given the sign. That means we will have to calculate according to the angle. Let's just plug in the values. That would be F into D into sine 45 degrees. And it really doesn't matter if you thought that you had to take this other angle, the other angle would also be just 45 degrees. So sine 45. Sine 45 would be sine 45 would be under root 2 over 2 f t. And then you might say under root 2 over 2 is none of the options given over here. Well, this is something very common in maths as well, and that is the calculator in fact gives you the answer in surd form. And in surd form, you usually see the roots or whatever irrational value up in the numerator, and it's not put in the denominator. In this case, you can see it's in the denominator. Well, an easy way to then convert this is basically you just multiply it with whatever irrational value was there, right? This is a mathematical concept, but it usually also comes in physics, so it's a good thing to remember it. So if you see under root 2 over 2, and if you need to bring it into such a value, which would be 1 over under root 2, then you just basically multiply the entire fraction with whatever irrational value is in the numerator. In this case, under root 2 over 2. You multiply them, you will get your final answer as fd over under root 2. So option A is the correct answer. Question 12. A couple consists of two forces, each of magnitude f, that act in opposite direction in the same plane. The perpendicular distance between the two forces is d. What is the torque of the couple? The torque of the couple would be f into the perpendicular distance. One of the forces into the perpendicular distance. Option C is the correct option. Question 13. A diagram shows an experiment to determine the force exerted on a ball by horizontal airflow. The ball is suspended by a light string and weighs 0.15 newtons. The deflection of the string from vertical is 30 degrees. The ball is in equilibrium. What is the force on the ball from the airflow? Alright, we're given a lot of forces over here. We are given airflow, but that's not the only force. If you notice carefully, you have a string. The ball is attached to some string. And wherever there is some force exerted on the string, there would definitely be tension. And naturally, you can understand as well, it's a ball. It must have some mass. If it has mass, it will also have some downward force. That is the weight. You will now see that we have a lot of forces. They're asking us from here airflow only. So the best thing you can do is make a simplified diagram of all of the forces as we usually do. All right, make sure you have the x and y axis because we will be simplifying these forces in the x and y coordinate, x and y directions, and then work it out very easily. So T is at an angle, and we can label the angle vertical over here. From the vertical, that angle is 30 degrees. So from the vertical, that angle will be 30. And by the property of alternate angles, again, this is a thing about maths, which means alternate angles. Suppose you have two parallel lines and a line intersecting them. The alternate angles will be equal. In this case, if I just visualize this, if I just turn it in one direction, we have one line of the y coordinate and the other line which was the vertical of t, and then we had this some sort of line passing through it, and we said that the angle over here is 30. The other angle forming would also be 30 degrees, which in this case is 30 degrees. Alternate angles basically. All right. So we have figured that out. Now let us label the weight. The weight is obviously down. What is the weight? The weight is 0.15 newtons. And we have airflow, which will be acting over here. I'll tell you in a moment why I made the airflow in this direction and why not in this direction. Let's label this airflow as F. All right. So the question itself has mentioned that the ball is in equilibrium. Whenever an object is in equilibrium, the sum of all the forces, or basically all the forces acting on it, will cancel out. In this case, we have three forces, F, W, and T. We can't really see if they're cancelling out or not. So the best thing we can do is basically simplify into the x and y direction. F is already in a x direction, W is already in a y direction. What is not in a x and y direction is the tension over here. So we can make its components. In this case, one of the components is Ty, and one of the other components will be Tx. So now you can see what is going on over here. F force must be equal to Tx. The force F over here, airflow, must be equals to Tx. But we do not know what is T in the first place. Well, if you stretch this T down over here, which you can obviously as well do, they will still cancel out, so you can still apply it. Using that, you can then mark this angle as 30 degrees. Another property comes into place whenever you're having two angles facing each other across a point. These vertically opposite angles, as they are called, will always be equal. You can also label this as T. Why did I bring this T down? Because we have the weight down as well. Now you can see what we're having over here. We're having T, we're having angle 30, and we're having W, which means we can now calculate T in this relation. We can consider W as the horizontal component of T. Alright, so the horizontal component of T, 0.15. In this scenario over here, we need to calculate T, and the angle over here is cos 30 degrees. So now if we rearrange and solve for T, let us see, it's 0.15 cos 30, and we get our answer as 0.1732 newtons. So now we have found T. T is equals to 0.1732 newtons. Alright, now I had just mentioned over here that this is some sort of horizontal component of T, but do not just equate it directly to Tx. That's not entirely true. Look according to the angles. 30, 90 minus 30, that would be leaving us with 60 degrees over here. Alright, so we have angle of 60 degrees now over here. Now we can calculate Tx. So let us see. Tx, which would be equal to F, will be equal to 0.1732 newtons multiplied by cos 60 degrees. So that would be cos 60, and we get our answer as 0.0866, which is approximately equals to 0.087. Therefore, the correct option is option B. Now you can see they're also equal. You can also double check the forces are really balancing out. Something I did not mention over here is the force Ty. That's completely unrelated, but of course that will also be equal to just 0.15, but that does not help us in this scenario, so we just ignored. So yes, 0.087 newtons will be force of airflow. Option B is the correct answer. Question 14. Two solid cylindrical objects X and Y are held fully submerged in a liquid as shown. Objects have the same volume. The density of material Y is twice the density of material of X. Both objects are stationary. Which statement is correct? Okay. The force due to the liquid acting on top of surface X is greater than that acting on top of the surface y? Well, let us see. If you look closely, force due to the liquids acting on the top of surface x is greater. It is not true. If you look at the height in this case, y is at a greater depth. The depth of y is greater. The top surface of the depth of object y is greater than that of x. Y should have a greater pressure on the top, or basically a greater force. Option A is correct. The depth over here from the top surface is larger for y, not for x. The pressure difference due to the liquid between the top and bottom surface of x is the same as that for y. That's not entirely correct due to the differences in the density. So the pressure difference due to the liquid between the top and bottom of the surface x is not the same as that for y. And also because the top and bottom are at a different depth. Option C, the upthrust acting on s is the same as the upthrust acting on y. Well, that is actually correct. What is the formula for upthrust? Formula for upthrust is density into the gravitational force into the volume submerged. We can see that they had mentioned they both have the same volume. So volume is same, gravitational force is of course same, density. Now do not just confuse this density with the density of the objects. The density in this formula is the density of the liquid, and both of them are in the same liquid, so density will also be same. So u will be same for both of them, upthrust will be same. The mistake that can happen over here is that students may just put density of the objects into the formula and then compare the values. No, that is wrong. This is not the density of the objects, this is density of the liquid. So option C is the correct answer. Question 15. An electric car travels at a constant speed of 70 kilometers per hour for 80 kilometers on a straight horizontal road and uses energy E from its battery. The total resistive force acting on the car is proportional to speed squared. Assume that the electric motor is 100% efficient. How much energy is used from the battery when the car travels at a constant speed of 60 kilometers per hour for 80 kilometers on a straight horizontal road? Alright. Now they're asking us about how much energy is used. Now, this question might look very complex, but let us break it down step by step. From the first thing, that what data are we given? First of all, we are given some initial velocity. Initial velocity was 70 kilometers per hour. And we were given some initial distance, which is 80 kilometers. Now, let us also note down what we have. We had final velocity as well. The final velocity was 60 kilometers per hour, and we also had the final distance as 80 kilometers. And what is basically the question? The question is asking the amount of energy the car uses from the battery. We basically just have a car traveling on a road, and the amount of energy basically it is exerting from the battery, right? Or in other words, you could say the driving force. That is also equals to the work done. An important thing to note over here is that it's traveling at a constant speed. That means it also has some resistive force, obviously, because they are mentioning the formula for resistive force. That resistive force will also be equals to work done. Why? Because if these forces will be equal, only then the car will travel at a constant speed. I'll tell you why in a minute we were considering this. Right, so basically they're asking us to find the work done. Energy over here is basically equals to work done. Alright, so we can use the formula of work done over here. And they're asking us how much energy is used from the battery with the car travels at a constant speed for 80 kilometers. And if you see the answers, they are using this mysterious E value. This E is basically the initial energy. You can see there is some sort of ratio being employed over here, because if these would have been just constants, then you would just have to calculate the final work done, which would be force into distance simply. But in this case, they're having this additional E over here. That means they're asking you to give it in terms of the original amount of energy. So let us consider this initial E as just E, because it's given the question as E. This E will be equals to force into distance. We do not know what is force, right? Well, we know it. We were given a formula over here. that the resistive forces will be directly proportional to speed squared, which means Fr will be equals to k speed squared. And as I mentioned, it's traveling at a constant speed. If it's traveling at a constant speed, the F resistive force must equal the F driving force, or the basically the force applied by the battery or the car itself, which is also equal to the force applied by the battery. The distance, and we have the force in that direction as well, which will be k into the speed square. Substitute that over here. That would be k into the initial speed, 70, squared into 80. Let's just keep that in that form and I'll tell you why. EF. Now the final energy we need to calculate. Again, we'll apply the same principle. It's equals to work done, which is then force into distance. We have the distance covered 80 kilometers. But which force is applied in that direction? It would be the resistive force, because that is equal to the driving force. So again, k into s square. S square over here, we would have 60. 60 squared into 80. Alright, so now they're asking us in terms of E. Well, that is very simple. We can just simply put the ratio over here. We can just put this in a ratio form. EF over E, and I'll tell you why. Because if you put these in such a ratio form, you can get E ratio. So EF was K into 60 squared into 80. And we had ESK into 70 squared into 80. Now the reason why I said you to not multiply and get a huge value from this was because we can just simply cancel out these 80 and this k, simplifying our calculation to 60 square over 70 square. And if you calculate the value for this, let us see, it would be 60 square over 70 square. That would be equal to 0.73. And now you can bring the e from the denominator to the numerator. That would be 0.73. You can see 0.73 as the option A. So option A is correct. Usually for these questions, if you see some sort of unit being used or some sort of extra variable that's being applied, look for that variable in the question. If there is that variable, that means it is almost always certain that there will be some sort of ratio method being applied to that question, just like we did over here. So it is a guarantee that such a ratio method will be definitely applied. Question 16. What is meant by the efficiency of a system? Total energy input to the system divided by useful energy? No, it is equals to the useful energy, useful over E total. So let us see, useful energy output from a system divided by the energy wasted? No. Useful energy output from the system divided by the total energy input into the system? Correct. C is correct. Question 17. An object of mass m is raised through a vertical height delta h. The gain of its gravitational potential energy is delta EP. Delta EP and delta h are related by the equation delta EP is equals to mg delta h, where g is the acceleration of free fall. The definition of which physical quantity is needed to derive this equation? Alright, so it cannot be just acceleration. Acceleration is equals to change in velocity over change over the unit time. That does not make any relation with this. Neither is it momentum, because there is no velocity being involved over here. And it's also not power. Let's look at work done. What is work done? Work done is force into distance. An object that is falling under free fall is also covering some distance h. So if you take that into terms, you would have force as mg, which is of course its weight. It's falling under the force of its weight. That would be multiplied with the height, or change in height in this case. And then you would get mgh. You have basically derived this equation above. Option D is correct. Question 18. Three identical springs, each of the same spring constant, are connected together in four different arrangements as shown. Which arrangement has the largest spring constant? Alright, so now they have said to us each with the same spring constant. Whenever they are saying to you that this certain value is this or that, or they're giving you some sort of relation, that means you must assume some values for it. Let us assume the spring constant as suppose 5. So now let's calculate one by one what would be the effective spring constant for all of these. This combination has parallel springs and in series springs. The formula for series springs, we will have K effective as 1 over K plus 1 over K2, 1 over K1 plus 1 over K2, and so on. And for parallel springs, you would have the effective K constant as K1 plus K2, and so on. So we can now apply this over here. The effective K constant for A, let us see, 5 was the assumed value which we took. You could also take 2, for example. Any value which is easy to work with is fine, but you need to assume some value to make the process easier to work. We have these both in series. That means this would be 5 inverse plus 5 inverse plus what? This is basically equal to the same thing. K inverse plus K1 inverse plus K2 inverse and so on, whole inverse. That is basically the whole formula. Oh yes, and K effective actually is not just K effective, it is 1 over K effective. Yes. So basically it's equals to K inverse 1 plus K2 inverse 1 whole inverse. Apply this over here. So this was for the series springs, and then we have one huge parallel spring. Over here, then we would just add 5. And let us work this out. This will be inverse plus 5, 5 inverse plus 5 inverse, and we would have over here 7.5. Now let's look at the next one. We have 3 springs in parallel. That means we will just add all of the spring constants together. 5 plus 5, 10, 10 plus 5, 15. We would have 15 over here. Now let's look at this spring combination over here. Whenever you're having this separation in between, consider this as one separate system and then this as one separate system, and then try combining it. Alright, so do not just consider these to be in series and then try working out from there. That would be the wrong method of working. So let us see. These both are in parallel. That means they would have effective spring constant of 10 combined, 5 plus 5. But this over here will be then in series, and that would mean that it would be 10 inverse plus 5 extra inverse whole inverse. Now let us calculate for this. 10 inverse plus 5 inverse whole inverse, and we would get our answer as approximately 3. Okay, and then this we have 5 5 5. This will have actually the smallest. So 5 inverse plus 5 inverse plus 5 inverse. So the effective would be 1.6. So we can see the largest combined spring constant will be for this system. And B. Question 19. The force extension graph for a wire is shown. Which row could identify the labels X, Y, and Z? Alright. Region of X. Well, that is not the limit of proportionality at all. It's the region of elastic deformation. Yes, that's true. Because you usually have the limit of proportionality, and sometimes you have the elastic limit at the limit of proportionality, sometimes you have it at a higher. But for this question, let us just assume it is on the limit of proportionality, because we're not given extra information. So it's definitely not limit of proportionality, it's a region. X is a region. So this option A would be wrong. Option B would also be wrong. C would also be wrong. Let us look. Over here we have region of elastic deformation as X. That is correct. Region of plastic deformation, well, that is beyond the limit of proportionality. So it would be Y. And then you have limit of proportionality. Limit of proportionality is a point, not a region. So that would definitely be Z. Option D is correct. Question 20. X and Y are 2 points on the surface of water in a ripple tank. A source of constant frequency generates a wave which travels past X and Y, causing them to oscillate vertically. What is the phase difference between X and Y? Now, they're asking you about the phase difference, but then you would notice that they have not given you any values or any distance basically between x and y, and neither they have given you any scale. How can you work out the phase difference now? Well, do not panic. The first thing, what is phase difference? Phase difference is the distance x between the points over the wavelength multiplied with 360 or 2 pi if you're working in radians. Alright, now they might have not given us the distance and neither the wavelength. But can you see that they are the waves and the crests over here? Using that, we can segment these to find out the wavelength first of all. Let us consider one wavelength, right? One wavelength in this case would be from this point to this point. So you can see how I've just segmented one wavelength. One wavelength would be one trough and one crest. And obviously it can also be from one crest to one crest. Or it can be from one trough to one trough. But for the sake of easiness, we're just taking it closer to the x and y points. So we can see that x and y, this would be the one wavelength. So we have lambda as 1. But we still cannot work out with this question. We do not know any scale. Well, another thing to notice is that x is at the start of the wave or the wavelength segment over here. So that means it will be at 0 degree initially. And then any point at the half would be 90. And then any point in the middle would be 180 degrees. Working out like this, we can get to y point that would be 270 degrees. And then at the end, we would have 360 degrees. So we know y is at 270 degrees and x is at 0 degrees. So that means 270 minus 0 degrees. The phase difference is d. Literally, you can work out from the phrase itself phase difference. Difference of the phases as at x and y. At y it is 270, at x it is 0. Subtract them, 270 degrees. So these are one of the ways in which you can find phase difference. If you're not given lengths values or x and lambda values, try working out with the angles itself on the wave. Remembering that initial point is 0, the first crest or first trough's mid will be 90, exactly halfway would be 180 degrees, exactly at the end it would be 360, and so on. Question 21. A transfer wave on a rope has wavelength lambda and a period t. The graph shows the variation of the displacement of the particles of the rope with distance in the direction of travel of the wave at time t equals to 0. A particle x is labeled. Which graph shows the variation of displacement of particle x with time t? Alright, this question is really easy if you draw it with an example graph. So they are saying with the variation of time t, what will happen or what will be the displacement of point x? Well, you can start by tracing out the position of x after set times. So initially, we know it starts over here at 0 point, as we can see. And then, how do we know where is x going to move? Well, you can see this line. This is the path which x is going to follow. X after some time will be here, then here, then here, then here, and so on. So now let's work out from there. That means x will be going up, or will it be? But it won't actually be going up because look over here in the direction of travel. Now, because we have noticed this direction of travel, this is actually an important thing to notice. We just considered that it would go first of all up. But now they have said that the wave would actually be traveling in this direction. That case of where x would be basically going up would be if the direction of travel would be in opposite direction. In this case, it is straight up front. That means you will follow the point in the opposite direction. So simply keep x stationary and in your mind try imagining pulling this wave and bringing it a bit of offset in this direction. We could also sketch it. Suppose over here the wave started. I could bring this wave to be over here, right? I pulled the wave a bit to this direction. You can see what's happening. The x point is now going down. That means you need to pull the wave in your mind. Try pulling the wave as a string in the direction of travel. So once you have figured this thing out, you can work out the graphs. All right. So let us now see. So the wave is traveling in this direction. That means we're going to work out as if the wave is being pulled in this direction. Point X will remain, of course, right now over here. And let us see how will it move in terms of up and down. So wave is going, the first path it will go will be down. All right, it will go down and then it would curve upwards. So we will also curve upwards and then it will be at a 0 point. 0 point we have also reached, and then it will peak on displacement. Over here also peaks on displacement. So let us now compare which one matches the best. So let us see. Remember, the initial part was straight. It won't be this, of course. Initial part must be down. Also not this. Initial part must be down. Obviously this is also wrong. Let's see for option C. This one is correct. It is starting from down, and of course the rest part we may have not traced it, but that's of course what will happen to the point, because there is the wave as well over here. It's just that the graph is cut and is obviously not this. It is going like this, though the wave should be going like this. So option D is also wrong. Correct option will be C. Question 22. A source of sound waves is moving at a constant speed directly towards the stationary observer. The sound waves have a speed of 340 meters per second and a frequency of 40 Hz. The observer hears sound waves of frequency 650 Hz. What is the speed of the source? Alright, so this is basically a question about Doppler effect. So that would be F observed is equals to the frequency of the source into V over V plus minus Vs. So 650 is equals to 480 into 340 over 340 minus. Why minus? Because the source is directly moving towards the observer, and also because you can obviously see over here 650, the observed frequency is more than the frequency of the source itself. This denominator over here 340 minus V must be smaller in order to give a larger frequency. All right, so Vs would be then approximately 89 meters per second. So option A is the correct option. Question 23. A student is investigating two electromagnetic waves X and Y in a vacuum. Wave X has a wavelength of 5.2 multiplied by 10 to the power minus 7 meter. Wave Y has a frequency of 9.4 gigahertz. Which principal regions of the electromagnetic spectrum contains wave X and Y? Well, the first thing is that we need to compare these two values, wavelength and frequency, and we can only do that if we convert either one of them to the same type, either frequency to the wavelength or wavelength to the frequency. Let's convert the frequency to the wavelength. So let's convert frequency of wave Y to its corresponding wavelength. 3 multiplied by 10 to the power 8 is the speed of the electromagnetic waves, and 9.4 gigahertz means 9.4 multiplied by 10 to the power 9 hertz into wavelength. Wavelength then will be equal to 3.2 multiplied by 10 to the power minus meters. Alright, so now we have got the wavelength, and now we have also seen another relation, that wavelength of Y is basically greater than the wavelength of X. Well, now to further clarify this question, it is best that you draw always for such questions a spectrum, right, of whatever waves are being shown. Just a small spectrum of what waves are given. So let us start with radio waves. After radio waves, we have microwaves. Then after microwaves, we have infrawaves, infrared waves, and then visible, and then ultraviolet, and so on. Gamma rays and X-rays we don't need to include because it's not part of the question, so we don't waste time on that any further. All right. So as you go down this spectrum, the wavelength decreases, but the frequency increases. Now let's compare accordingly. First of all, X as a radio wave, okay, and Y as ultraviolet. Well, that is wrong. This means that Y will have a smaller wavelength than X, which is wrong because Y has a greater wavelength. So option A, absolutely wrong. Option A is wrong. Option B, ultraviolet and visible. X is ultraviolet and Y is visible. Now this seems correct because now Y has a greater wavelength than ultraviolet. But here is another thing to notice. Visible light usually has a frequency between around 7 multiplied by 10 to the power minus 7. They have the wavelength, in fact, between 7 multiplied by 10 to the power minus 7 meters and around 4 multiplied by 10 to the power minus 7 meters. Some approximate values. The key takeaway over here is that they have wavelength the power 10 to the power minus 7. And if we look over here, the wavelength of y is 10 to the power minus 2 multiplied by 3.2. This 10 to the power minus 2 is considerably bigger than 10 to the power minus 7. This means y just can't be visible. But this also gives us another hint that x can be visible because it has 10 to the power minus 7 in its wavelength. If we now look at the second, if we look at the third option, option C, x visible, yes indeed, and y microwave, of course, and that also matches. We could make x as the visible and y as the microwaves, and that will make sense. Now y has greater wavelength, which matches according to its number over here, 10 to the power minus 2, and x has visible, which also matches to its wavelength with visible light. So option C is obviously correct. So the important thing about this question is that you must know at least a few values of typical frequency of the wavelength, either the frequency or either wavelength, because if you know one or the another, you can calculate the other value. So I think so if you memorize for visible and for border wavelengths like radio waves and microwaves and like gamma rays, then maybe this question would be easy for you. Generally speaking, it's a rare question, and to be honest, such questions appear rarely. But just to be extra safe, it's best if you just remember the powers which are associated with each of the waves. If possible, you could memorize the entire wavelength. That would be well and good. But the important thing is for visible light, you should know that it is 10 to the power minus 7 for the wavelength. On to question number 24. A plane polarized light of wave intensity is I is incident normally on a polarizing filter. The initial intensity of the transmitted wave is 0. A second polarizing filter is then inserted between the source and the first filter. Its transmission axis is at 45 degrees to the transmission axis of the first filter as shown. What is the intensity of the transmitted wave from the filter combinations? Now, take a step back and first analyze. This is not our typical question of Polaroids and wave intensity, because in this case, our second Polaroid is inserted over here and it's not inserted after this first filter, and that affects a lot of stuff. So what do we know? We have a source of polarized light, so it is polarized. That means it is not in this form, unpolarized form. So we know that the wave is not in unpolarized form, it is in some polarized form. But in what plane? They have given us this information. The initial intensity of the transmitted wave is 0. So imagine this filter isn't there. So according to this transmission axis, to get 0 intensity of transmitted wave, the plane of polarization, or basically the polarized light, must be polarized at a perpendicular angle, and only then the transmitted wave would have 0. That means that the wave is polarized horizontally. That is one key takeaway. If it would have been polarized vertically, then the transmitted wave's intensity should have been 1. But in this case, it is 0. So it will be horizontal and perpendicular to the first filter. So now we have found out the plane of polarization, a very important thing, so that we can calculate the theta angle, which we will use in calculating intensities. So now let's look at the first transmission filter. Right. So we know that it is at 45 degrees and the source of polarized light is also horizontal. That doesn't impact the angle because the angle will still be 45 degrees. So we have found the angle for this first Polaroid. So we can now calculate, suppose this is I1, and I'll name this second intensity, the final one, as I2. Let's now calculate I1. That will be I0 multiplied with cos square 45. Why 45? Because the angle between the plane of polarization of the incident light and the transmission axis is 45 degrees. So I1 basically is IO over 2. All right. So now we need to calculate I2. As we just said that the angle of the plane of polarization is now at 45 degrees. So now we're going to assume, not assume, in fact, it is now going to be at 45 degrees. The new plane of polarization will be at 45 degrees. So we can even draw that on the Polaroid. And if you look over here, it will be at 45 degrees. And because now it is 45 degrees, the angle between it, the plane of polarization of the incident light, and the transmission axis of first filter will also be 45 degrees. If we wouldn't have noted this, we would have just said, okay, cos square 0, because this is just a straight transmission axis. So we would assume it's 0, but it's not 0 in this case. In this case, it will be 45 degrees. So let's now calculate I2. I2 will be I1 into cos 45 squared. And that would be I1 over 2. As said, 45 degrees was the theta angle between the transmission axis and plane of polarization of the incident I1. But we are not going to stop here because the answers are given in IO. So I1 is equals to IO over 2. That is equals to IO over 4. And therefore, your option is C. Question 25. What can explain how stationary waves are formed from progressive waves? Alright. Diffraction? No. Polarization? No. Superposition? Yes. Two waves of same amplitude and frequency traveling in opposite directions must overlap or superimpose in order to form the stationary wave. So option C is the correct answer. Question 26. A pipe of length 2 meters. It is open at one end and closed at the other end. A stationary sound wave is set up within the pipe. There are 4 nodes and 4 antinodes within the length of the pipe. What is the wavelength of the sound wave? Alright. So if you think this question is still difficult to understand, one always good trick which I usually do in such questions is that I draw the wave. It's best if you just sketch out a wave. We have node to node, from other node, and so on, making sure it is real like this because it's an open end. Similarly, we're going to sketch the other wave component like this. Now we have a rough idea of what kind of stationary wave is being formed. So they're asking us, what is the wavelength of the wave, of the sound wave? Well, now that we have drawn the stationary wave, we can easily identify it. Over here, we can see that we have one wave. From this point to this point, we have one wave. And then we have from this point to this point, we have basically 1 and 0.5. That would be one wave plus 1.5 wave. That means we have 2.5 waves, right? So you could now either do it through the calculation that the distance between two nodes is basically lambda over 2, and you could relate it with 2.5. So if 2.5 waves have 2 meters and the distance between lambda 2 is this much, so what would be the lambda in this case? But this is a lengthy calculation which I was just about to perform. There is in fact a simpler method, but that simpler method also does not give us the correct answer of 1.1. Question 26. A pipe has a length of 2 meters. It is open at one end and closed at the other end. A stationary wave is set up within the pipe. There are 4 nodes and 4 antinodes within the length of the pipe. What is the wavelength of the sound wave? Alright, so for such questions, it is usually best that if you sketch a stationary wave. It helps to identify where a wave is forming, and it is also good practice because it helps you identify what number of waves are within the pipe. So here I've roughly sketched what is the wave. Now they're asking us what is the wavelength of the sound wave. So we know that the distance between one node to the other node, right? From one node over here to the other node, the distance is lambda by 2. And how many nodes we have? We have lambda by 2 over here as well, and lambda by 2, wavelength by 2 over here as well. Over here we have node and an antinode, which means the distance between the node and the antinode is lambda by 4. Now you could either do this in two ways. You could either count the number of waves, which in this case would be 1, 1 and then 0.5, 2.5 and then calculate through ratio, or there's a simpler way. 2 meters is the total length. This 2 meters is equals to lambda by 2 plus lambda by 2 plus lambda by 2 plus lambda by 4. How did we figure this out? Through the fact that the distance between nodes is lambda by 2. The first and the second, lambda by 2. Second and third, again lambda by 2. Third and fourth, again lambda by 2. And then we don't have a node for the, we don't have the node for a fifth one. There is no fifth node given to us, but we do have an antinode. So the distance between one node and one antinode is lambda by 4. And we can equate all of this combined, and their sum should be equal to 2. So we can then make up this equation. And then we can just simply put this in the calculator, and that would be lambda by 2 plus lambda by 2 plus lambda by 2 plus lambda by 4. And we would get our answer approximately as 1.1. Question 27. A teacher is explaining diffraction to a group of students. Which piece of apparatus is most appropriate for the teacher to use to demonstrate diffraction? Alright, let's see. A long spring? No. A ripple tank? Yes, because a ripple tank can be used to make ripples, and we can also put the obstacles in it in order to show the effect of diffraction. Rope, long spring, stretch spring really cannot show all of them. We can best see the wave fronts and the ripples basically along with the wave fronts in a ripple tank. And usually this is related to the very common ripple tank experiment. It is commonly used to show the effects of waves, reflection, refraction, and most importantly, diffraction. So for question 27, the correct option. Question 28. Coherent light of constant wavelength is incident normally on a double slit. Interference fringes are formed on a screen that is a fixed distance from the double slit. The screen is parallel to the double slit. The separation of the slits is varied. Which graph best shows the variation with slit separation A of the spacing x of the interference fringes? Right. So first of all, usually for this kind of question, I always go with the relative equation. You could make this x value or whatever value is on the y make equal to x. Mostly it is involved with maths, and if you know maths very well, this question should not be much difficult, because if you can equate the right equation with the graph, you can easily spot the shape. For this question specifically, we are talking about double slit, and the equation for relating double slit is lambda is equals to, the wavelength is equals to a x over d, distance from the screen. Right. So the goal basically should be to rearrange this equation such that you can get out or basically extract the relation between x and a. So we can arrange this equation, that would be lambda d over a is equals to x. And we can then extract this relation from it, that 1 over a is directly proportional to x. Now, if you look closely, for math students, you can notice This is equals to, or this looks like the graph of y is equals to 1 over x. Such kind of equations basically give you a parabolic graph which has a shape like this. And if you look over here, we have the same shape, considering x could be our y and a could be our x value over here, which is true because a is on the x-axis and x over here, the fringe separation is at the y-axis. So therefore, we can see that the graph must be like a hyperbola. So it can't be B, it can't be D, it can't be C. The option correct one is A. Usually many questions like these appear, so it's common to know the shapes and the equations of these graphs, like the graph of x squared would be a parabola and so on. Question 29. Light of wavelength 690 nanometers passes through a diffraction grating with 300 lines per millimeter, producing series of bright spots maxima on a screen. What is the total number of bright spots that are produced? Alright, so the first thing, note down what is the equation. D sine theta equals to n theta. Do we know D? Yes, we need to just calculate it. So D is equals to the distance between the slits. In this case, we do not know the distance between the slits, but we know the number of lines per millimeter. If we basically inverse that, we will get D. That would be 1 millimeter over 300 lines. But we do not need millimeters. We need it in meters. That would be 1 divided by 10 divided by 100 over 300. That would be 1 divided by 10 divided by 100 over 300. That will give us 3.33 multiplied by 10 to the power minus 6 meters. All right. So we know that 3.33 multiplied by 10 to the power 6 meters is the D. 3.3 multiplied by 10 to the power minus 6 is the D. Now we do not know what is the angle, or do we? We do know the angle, considering that this is the zeroth maxima. The maximum that you can view on the screen is still here. Obviously, you cannot view beyond it because there's no screen after that. So we can see clearly that this spans all the way to 90 degrees. So we can assume that the maximum possible angle that you can take is sine 90, right? We need to figure out the number of the maximum that will now form. And the wavelength we know is basically 690 nanometers, so multiply by 10 to the power minus 9. And now we can solve for x. Sine 90 is 1, so 3.3 multiplied by 10 to the power minus 6 will be equal to the number of maxima 3 multiplied by 10 to the power minus, and we would get our answer as 4.78. Now obviously n cannot be a fraction, it can be a whole number. So the best thing is you are going to round it down, because you can't just round it up. Where will you get that extra maximum from? 4.78, you can't just round it up to some extra maximum. So most reliably you can round it down to 4. That means there are 4 maxima. 1 2 3 4. 1 2 3 4 maxima. But that is not the final answer. There will be 4 on the other side as well. 1 2 3 4. There will be 4 maximum on the other side as well. That would make the total as 8. But still that's not the right answer, because you have a maxima at the center, the 0th maxima. Adding that to it, you will get your answer as option D, 9. And if you think you're getting confused by this method, there is another method as well. You could just simply take sine, you could just simply put in the angle. We could just take any angle. We could keep sine as x. We could do it in the opposite manner basically. So the method is, instead of writing sine 90, we could just write sine, put it into the calculator, write it as sine theta, and substitute into it values of n starting from 0. Then go on to 1, then 2, then 3 and 4. Basically, it's a hit and trial method. So keep on doing this until you hit a math error. This basically means that you're reaching such a fraction that sine inverse will be invalid at that point. And in that case, n is basically equals to 4. So sine theta is valid till n is equals to 4. Beyond that, it just goes invalid. So if you put n5, sine the theta will give you an invalid answer. That is one of the methods, hit and trial. Or you could go directly, assuming that it's 90 degrees maximum over here. So n, whatever value which you'll get, you'll always round it down, right? And then that will be the maximum one side. Add it to the other, and then add the center maxima as well to get the final number of total maxima that are produced, bright spots. Question 30. A fine mist of oil droplets is sprayed into air. As the oil droplets leave the nozzle of the spraying device, they can become electrically charged. What is not a possible value for the charge of an oil droplet? Alright. So they have said that they can become electrically charged. That means 0. Obviously, it's not going to be the answer. And to find all the rest of the answers, all you have to do is to divide it by elementary charge. And the elementary charge is 1.6 multiplied by 10 to the power minus 19. You're going to divide it with all of these values and see if they give you a whole number. The option which gives you a whole number will basically be the correct answer. In this case, option B is correct. We divided 1 multiplied by 10 to the power minus 19 over 1.6 multiplied by 10 to the power minus 19. We will get the answer as 5 by 8 or 0.625, which is again not a possible value. If you do it for this and if you do it for this, you will get a whole number, which means these are valid answers because electrons can only be in whole numbers. Option B will be wrong because this will give you a fractional value. Electrons can't really be in fractions. Option B will be definitely incorrect. Question 31. In the circuit shown, a fixed resistor X is connected in series with a battery and a variable resistor. The power dissipated in resistor X is 7.2 watts when a current of 3 amps passes through it. The variable resistor is adjusted so that the power dissipated in X increases by 50%. What is the new current in the circuit? Alright, we are overwhelmed by a lot of data again. The best thing we can do is note down what we already know first of all. 3 amps passes through the entire circuit. Alright, and can we calculate the resistance? Yes, we can. Why am I saying to calculate resistance? Because this is a fixed resistor. If we calculate resistance, we can interpolate the resistance with the initial data and the final data, which is 50% increased. Because if you're going to work with potential difference, that will be unreliable. You can also see that we have a variable resistor. Then we would have to calculate for variable resistor separately, and potential difference really would be difficult to calculate. But something that is much more reliable is the resistance, because they have said over here it's a fixed resistor. That is a value that will remain constant between the initial values and the final values. So initially, what was the resistance? Let us see. The formula is P is equals to I square R. P is 7.2 watts, I is 3 amps. We need to find R. Resistance would be 7.2 divided by 3 square. Resistance would be 0.8 ohms. Now they have said that they have increased the power by 50%. So first of all, let us note 0.8 is the ohms in X. Now they have increased the power by 50%. That would be 7.2 multiplied by 50%. That is the half plus 7.2. That would give us 10.8 watts. 10.8 is equals to, again, I square into 0.8 ohms, because again resistance will remain constant. So then we get the new current. That would be 10.8 divided by 0.8 under root. Get the answer as 7, which is approximate 7 amp. So the correct option is B. Question 32. The potential difference across a metal wire is kept constant. The length L and the diameter D of the wire are both varied. The type of metal is kept the same. How is the current in the wire related to L and D? All right. So the first thing we can do is find equivalent equations. Usually when we're talking about the substance and its length and diameter, we usually refer to resistance. But in this case, we are not referring to its resistance. We are trying to relate it with the current. So we need to somehow bring those current and length and distance and the diameter values together. How can we do that? First of all, let us know, we know that the resistance is equals to the resistivity of the metal or multiplied with L over D squared. Why D squared? Because it's diameter squared. Half it and all of that basically to get the circular cross section area, but that's none of the importance over here. Just D square is important because it's the cross sectional area. So R is equals to the resistivity into the length over D square, and V is equals to IR. So V over I is equals to R. So we can now equate these together. That would be V over I is equals to resistivity multiplied by length over diameter squared. So we can now extract the relation from this. That would be 1 over I is proportional to length over t square. Further simplifying this, we can just invert them all, and that would be I is directly proportional to d square over L. We have just basically inverted them. So now we can check the questions. So the current is directly proportional to L and inversely proportional to D. Wrong. First of all, option A and option C automatically cancel out because only D square is being considered here. Option B, it is directly proportional to L. No, it's inversely proportional. Option D, it is inversely proportional to L. Correct. So option D is the correct answer. Question 33. A student sets up the circuit. Circuit diagram shows how the positive and negative terminals of a voltmeter connect to the circuit. The voltmeter has an initial reading that is positive, which changes, if any, in temperature and light intensity would cause the voltmeter reading to decrease. Now this question might look difficult, but it actually really isn't that difficult. The first thing you need to notice is that they're saying that the initial reading is positive. That means there must be voltage in this direction, right? If it would be in the other direction from in this way, that would mean from positive to negative. That again would mean it's wrong. Usually it is from negative to positive. So that means that the PD across this thermistor must be greater than the PD across this fixed resistor. Suppose if the potential difference over here would have been like 5. So 5 volts is also going here. And then from the opposite side, we have something like 4. So combining them according to directions would give us basically 1 volts in that direction. And that is how we're seeing that its initial reading is basically positive. So what are they asking us now? Now they're asking us to reverse the basically voltmeter reading or decrease it. They're asking us to decrease the voltmeter reading. So how can we decrease it? Let us look at the combinations one by one. So for temperature, they've asked us to increase the temperature. To basically decrease the voltmeter reading, you have to decrease the PD across this and increase the PD across this. So if you increase the temperature, the resistance of the thermistor will decrease. So that means the potential difference will also decrease. That does achieve the requirement. For light intensity, if you increase now the light intensity, that would decrease the resistance, which means it would decrease the PD across this light dependent resistor. This means that the potential difference across this resistor would increase. Of course, not the resistance because this is a fixed resistor. So this is exactly what we wanted. Option A is correct. Other options really aren't correct. If we look at the other options, like option B, we have temperature, no change. If you don't change the temperature, so V stays at it as it is. And if you decrease the light intensity, the resistance across this, the PD across this would increase. But still, that really won't affect it much. So the greatest effect, or the greatest effect is done when you are simultaneously basically changing the PD across the thermistor and the potential difference across the fixed resistor. Rest of them don't really have that much effect. Option A is correct. If you look at option C, the temperature decreases, that increases the resistance. That's not what we want. And for option D as well, if you look, they are again decreasing the temperature, which would in turn increase the resistance of the thermistor, and that would increase the potential difference. So option C, D, and B will be wrong. So option A for this question is question 34. Some resistors and a battery of electromotive force EMF E and a negligible internal resistance are connected in series as shown. Which statement is correct? EMF across each resistor equals the potential difference across the battery. No, that's wrong. There is no such thing as EMF across each resistor. That is called the PD across each resistor. EMF is only across the source. Potential difference across each resistor equals the EMF of the battery. Right. So they're saying potential difference across each resistor. No, that's not correct. Potential difference, the sum of potential differences is equals to. That is also wrong. Sum of EMFs across, again, it's wrong. There is no such thing as EMF across resistor. It's only across. Option D, sum of potential differences. Yes, that. Option D will be correct. Question 35. Kirchhoff's first law is a consequence of the conservation of which physical quantity? Charge. Conservation of current, which is Q charge. 36. The diagram shows a network of resistors. Each resistor has a resistance of 6 ohms. What is the total resistance of the network between points X and Y? So this question might look very intimidating. Otherwise, it is a very simple question. You have to just calculate in parallel the effective resistance of this group, and then of this group, and then of this group, and then just add them together because these entire three groups are in series. So for the first one, it will be 6 inverse plus 6 inverse plus 6 inverse whole inverse. That would be 2. And for the other one, we have 1, 2, 3, 4, 5, 6. That would be 6 inverse plus 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 6 inverse whole inverse. That would be 1. Same would be for this 2. And when we will add these together, the effective resistance will be 5 ohms. So option B correct. The circuit shown, a battery of negligible resistance is connected in series with a pair of fixed resistors R1 and R2. The circuit is to be used to test whether the electromotive force of a particular cell is 1.5 volts. The cell is connected between terminals X and Y in parallel with R2 in series with the galvanometer. What statement about the test is correct? So, which statement about the test is correct? Any non-zero reading on the galvanometer means that the cell has an EMF of 1.5. Well, no, that is wrong. The first thing is that it should be a zero reading on the galvanometer. That's called the balance point. If this is basically about potentiometer equation as well. Thing is, to find this unknown EMF, we move the jockey over here. It's usually a jockey. You move it up and down the resistance wire. In this case, we just have these fixed resistors over here. But the point where you move it, if the galvanometer shows zero reading, that means it has reached that potential difference that is equal to that on the resistance wire, and therefore that should be the EMF. So non-zero over here is the wrong thing. It should be a zero reading. Option B, the battery does not need to have an EMF of 6 volts. Well, that is wrong, because if it won't have 6 volts, then according to the ratio, right, if you calculate 6 volts and how much PD will go across R1 and how much PD would go across R2, if this won't be 6 ohms, the PD across this will not be 1.5 volts. The cell may be connected either way round between X and Y. Well, for this as well, cell cannot be connected either way. It must be connected in only one direction. If it would be connected in the other way, it will never give a zero reading as a matter of fact. So option C is also wrong. Option D, the galvanometer does not need a scale calibrated in amperes. Yes, that is true because the main criteria over here is to just see and find out a balance point, a point where the galvanometer shows zero current. So it doesn't matter if it is calibrated in amperes and not in amperes. If it shows zero or basically straight line, if it says zero centered galvanometer, that means we have found the balance point. So it doesn't necessarily require calibration in amperes. So for question 37, option D is correct. Question 38, two nuclides are different isotopes of the same element. Which statement about the nuclides is correct? Right. Two nuclides are isotopes of the same element. That means we have X and we have Y, two elements. The nucleon numbers will be different, A and B, but the proton numbers will be same. Let's just name them as, right. Neutral atoms of the nuclides have the same number of electrons. Yes, that is true because the number of protons is same, and they have also said over here neutral atoms, not ions. Nuclei of the nuclides have different number of protons. No, rest of the options are wrong. Option A is of course correct. Question 39, the charge to mass ratio of a particle is given by the equation shown. The value of R is determined for an alpha particle, a beta plus particle, or a positron, and a proton P. Which list shows the particles in orders of increasing magnitude R from left to right? Right, first of all, we need to calculate this R for each of the particles. For alpha, it is easy. We have two protons, and we have mass as 4 because two protons and two neutrons. So the R for this will be 0.5. For beta plus particle, it is a bit different, right? The charge we know is plus 1, not negative 1, plus 1. This is a positron, not a beta particle. What will be the mass? Don't just consider that it's beta plus, so okay, just it's like a proton, so just make the mass as 1. That is wrong. Beta plus is an anti-particle. To what? It's an anti-particle to a beta particle. What is a beta particle? Which is the beta particle negative for the electron. So it is basically an electron on which it has a charge of -1 and a mass of 1 over 1840 approximately, because it is an electron. And because beta plus positron is an antiparticle, the only difference will be of charge, rest will be same. So the mass on this will also be 1 over 1840. 1 over 1840, basically 1, that is according to the mass of the proton, divided by 1840. And that is how we can say that its R value is 1840, because reciprocal over here 1 over 1840, it goes back up to the numerator plus 1840. So that's an important thing to note. Right, and lastly we have proton. So proton, that is just 1 plus 1 charge, mass also 1, that will give us just 1. So we can see from increasing, or in order of increasing magnitude, we have first of all alpha particle, so we can just cross out option C and D. First have alpha, and then we have the proton, not the beta, the proton first, and then lastly we have the beta positive or the positron. The correct option is B. The important takeaway over here is that it should be 1840 for this beta particle, because beta particle, this beta plus particle, is just an anti-particle to the beta negative, which is basically a fast moving electron. So the opposite of this would be a beta plus. The mass, that's why, is derived or taken from this beta negative particle. So it would be 1 over 1840, even 1 over 1839 in some cases, but approximately it's 1 over 1840. The correct option in this way is B. Question 40, which combination of up and down quarks forms a neutron? All right, so for this we need to know first of all charges on up and down. So charges on a up is 2 by 3. Charges on a down quark is minus 1 by 3. And a neutron has a charge of 0. So we can compare this one by one, but generally the answer is option C. Combine 2 by 3 plus minus 1 by 3 minus by 3, you will get your answer as 0. That is 2 by 3 minus 1 by 3 minus 1. Answer will be 0. And that means option C is the correct answer. And generally, it is something that you should memorize. The quark composition of neutrons and the quark composition of protons. You must know it because it is a common thing asked in paper 2 as well. They generally ask you about the composition of the proton and the neutron on quark level. So it's best if you do remember these by heart. And that was paper of October November 2023 done. I hope you had understood this paper. If you didn't, do leave a comment on which part you didn't understand, and do leave a like, subscribe, and I'll see you in the next video. Goodbye.